Good night, my CSEC Math scholars. Welcome to another live CSEC Math class. Today, being Monday, we will be focusing on graphs. If you're not aware of our schedule for live CSEC Math classes, here it is. Please write down these dates, times, and what sessions we have for each. Here you go. Hello CSEC Math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand. All right, so good night to everyone who is joining us from wherever in the universe you are joining us. Welcome to those on Facebook, on Twitter, on YouTube, and we also have some scholars in studio with us, and they're about to join me now on the screen. My faithful, dedicated, and brilliant studio crew. So I'm going to welcome Asar, and I'm going to welcome John, Imani.
Night, miss.
Welcome, faithful, devoted, loyal crew. This is echoing. Echoing?
No, miss.
Miss, not anymore.
Okay. All right. So good night, Ngozi, Jamani, Zion. Welcome to everyone. So what we're going to be doing tonight is we're going to be looking at solving simultaneous equations that involve one quadratic and one linear equation. Last week, Monday, when we did graphs, we looked at solving simultaneous equations using simultaneous equations that were both linear. I'm still hearing the echo. Hold on, give me a second.
Excuse me, miss, you're frozen on my screen. Can I rejoin, please?
Yes, both of you rejoin, please. Asara, rejoin, please. Let me check some. All right, so we're just trying to get rid of that echo that we're having. All right, welcome back, Imani.
Good night, miss.
Okay, so waiting on Asar to rejoin. In the meantime, so I was explaining that last week we looked at solving simultaneous equations by intersecting graphs, and those functions were both linear functions. I think we did one where we had a quadratic and a linear, but mainly we focus on the both linear. So that means we had two straight lines plotted on the same coordinate plane, the same graph paper, and we were able to take the solutions by seeing the point at which the two lines intersected. So each function would have one solution, which is a pair of x and y coordinates. So we'd get an x value, or should I say, let me repeat it, it's two solutions, one for the x, one for the y, right? Whichever way you want to look at that, as one pair or two solutions. What we're going to see for the quadratic and the linear, usually you're going to have two pairs of solutions, and this is because the quadratic function will produce a parabola, which is a curve, a uniquely shaped curve. If we have a line coming in and cutting that curve, most times that line will cut the curve at two places. And so that's why we get two x values and correspondingly two y values. It doesn't always have to be that way, however. The line could come in and not cut the parabola. It could happen. Or the line could come in at a tangent and only cut the parabola at one point. Although it could be said we actually do have two solutions, it's just that they are the same solutions. Could look at it that way. So we're going to see what happens when we do that. Let me just make one check on a matter and return to you. In the meantime, I'm going to share my screen with the GeoGebra software. All right, so tell me if you're seeing the GeoGebra up and running. Let me know if you're seeing
Yes,
the
miss.
GeoGebra. All right, so what we're simply going to do, normally, and if you're not familiar with how to plot equations on graph paper, plot functions on graph paper, I have many videos on that showing you how to plot a linear function to get your line, how to plot a quadratic function to get your parabola, and so on. If you're not familiar with how to do that, we're not going to focus on that tonight. Our focus is how to get the solutions where we have functions intersecting. solving simultaneous equations. So I'm just going to give you an idea, though, of how we would approach something like that. So just to give you an idea. So for example, if we had, let's say we had y equals x squared plus 5x minus 2, and we had, so that's the quadratic function, we see our x squared. And if we had the linear function y equals x plus 3, I'm just going to give you an idea of how we would get our table to plot our graph. But we're not going to dwell on that. So for the linear, if you're not given a domain, so if you're not told what your x values should start and end with, you could put in, choose your own domain, right? So we'd set up a table which would have our x values, and let's say throw in some negatives and some positives. So we could put -4. We like to see what's happening at 0, even though we really only need 2 points to make a line. But I like to know what's happening at the origin, so I always throw in 0 there. And then we go to our function and we write, so it's x plus 3, and this would give us our y value. So whatever x is, we would just put that back, and then add 3 to each of those. So we said -4 plus 3, that's -1, 0 plus 3 is 3, 4 plus 3 is 7. So we would plot -4 to -1, 0 to 3, 4 to 7, and we would have our line. So -4, -1, 0 to 3, 4 to 7, which will be up there, right? 4 to 7. For the quadratic, we would have to put in all our points, not just 2 or 3 points. We would need all our points because we're going to get a parabola. Right, so that line would go there. That would be the line for the linear. So when we put our x, we'd have to put from -4, -3, -2, -1, 0, 1, 2, 3, 4. And then we would square the x. So we'd have our x squared, then we'd have our 5x, then we'd have our -2 and y. So -4 squared is 16. 5 times -4 is -20, minus 2. So 16 minus 20, that's -4 minus 2 is -6. So we would plot -4 to -6, and do that for each of these points. And the graph would be a parabola looking that way, since the x squared term is positive. So just for argument's sake, it would come something like that. And then the two places where it's the line and the curve intersect, we would take our readings, right? So this is if you were doing it on your own. So you'd put this at the back of the graph paper or in your notebook, and then on the face of the graph, the coordinate plane, you would plot the linear, plot the quadratic, and see where the points intersect. So we're going to allow the GeoGebra to do that for us right now. So we're just going to plug in the coordinates and allow the GeoGebra to do the work for us, which is why we love our GeoGebra software. All right, so what I'm going to ask my scholars to do now I'm going to plug in the coordinates to get my curve and get my line. And then I'm going to ask each scholar, Asar, just turn your mic off unless you are speaking, okay? All right, so just keep your mic off until it's your time to speak because we're getting feedback, which cannot be avoided right now, okay? So going to ask each scholar to just take the solutions for me and also to plug the solutions back into each equation to see if they add up, to see if they make sense, right? So that's the task for each scholar. I'm going to plug in the two functions and we're going to see where they intersect. And each scholar will tell me the solutions, the two pairs of solutions, which is usually the case when a quadratic intersects a linear function. And then you're just going to quickly plug in those values into each function just to ensure that we are correct. All right, so John, I'm going to ask you to go first. So I'm going to plug in. So y equals x squared plus, hold on. All right, so I'm having an issue here where I'm typing the x square and it's not allowing me to leave the index. So that's my issue. I need to get the x square out of the index. Any suggestions as to how to get that plus sign?
Miss, I think you can try to press the down arrow and then press the plus sign. Maybe because you
I
typed it
was
square.
trying that.
Oh,
The down arrow.
yes, miss. Maybe because you need it. Yeah, see there. You can add
Okay,
it.
and space. Okay, so plus 5x. Thank you, Imani.
Miss.
5x plus, sorry, not plus, minus 2. All right. So this is it. Let me clear that one. Let me delete this one. So this is our function. Y equals x squared plus 5x minus 2. And then that's the quadratic. So the linear is y is equal to x plus 3. All right, John. So these are our two functions. One linear, one quadratic. All right. So I want you to tell me, John, what the solutions are. And then you're going to quickly plug them in. Plug them in and tell me what the solutions, if the solutions are correct.
Okay.
What are the solutions? remember, the solution is where the linear intersects with the quadratic.
Yes, miss. It's just
Oh,
1 to 4.
pardon me?
It's 1 to 4. Positive 1.
Okay, so you're saying right here.
Yes, miss.
All right, so that will be what is equal to 1, x or y?
Miss X
All right, so x equal 1
and Y equals
and
4.
y equals 4.
Yes,
All right, and what else?
miss. -6 to negative.
No,
Oh,
negative
yes, it's
5.
-5 to -2.
All right,
The
so
negative
negative
5 X.
5.
Miss, that's
So
X.
x equals
Negative.
negative 5 and
Miss Y is
y,
equal to -2.
y equals negative 2. All right, so when we find the points of intersection, we get your ruler, make a dotted line down to the x-axis, take your reading, dotted line over to the y-axis, take your reading. Same thing for over here. So x is -5, y is 2. Plug them in for me quickly, John, to see. So for the linear, y equals x plus 3. Let's see if that is so. So if we're saying y is 4, x is 1, so we'd have what?
It's negative
4 equals
3 and this one.
1 plus 3. So that works out, right?
It's
And the quadratic, y
this
equals
negative
x
5.
squared plus 5x minus 2.
It's
So let's plug in those values. So what would we have?
this -5.
We're saying we're doing these two first. So
Okay.
we're saying y is 4, x is 1. Let's see if it works out. So y is 4, and the x would be what?
This one squared plus 5.
1 squared plus 5 times 1.
Or 1. This is -2.
All right, so does this give 4?
Um,
1 squared is 1.
this is, and
5
5.
times 1 is
Yeah,
5.
yes, Miss gives 4.
All right, so let's check the other pair of values. So if x is -5 and y is 2, for the linear, we would have y equals x plus 3. So we're saying y is what?
Miss Y is -2.
So -2 equals
Negative
negative 5.
5 plus 3. Oh,
Is that correct?
um, Miss, yes, Miss.
Right. And for the quadratic,
Y is equal to x squared plus 5x minus
y
2.
is equal to x squared plus 5x minus 2. So we're to plug in -2 for y,
Y is equal to -2.
and x is -5. So -5 squared
Oh,
plus 5 times -5 minus 2.
Miss Y would be -5.
Because x is -5, though?
Oh, yes, Miss.
All right, so -2. What's -5 squared?
Miss, that's 25. That's one. That's
25.
positive.
And 5 times -5?
Miss is a positive 25 as well.
No,
Miss 5 times oh yeah, Miss that's
negative.
25, yes. Minus 2, Miss, yes, Miss, the answer is
So these
negative.
cancel out, right?
Yes, Miss, so it's
All
negative.
right. So we are correct then, right?
Yes.
All right. Asar, your turn.
Okay, miss.
All right. So I'm going to plug in y equals x squared plus 3x minus 6, and then y equals 2x minus 4. All right, so these are our, these
Miss,
are,
I hear the
mhm.
echoing.
No, go ahead, Asura, go ahead.
Okay, so the first intersection is -2, -6.
Oh, for this one, so right here, so what is -2, x or y?
X.
So x is -2, all right, and y is -6. All right, and for this one,
X is equal to -0 point.
here,
Oh, sorry, 1.
so x is 1 and y is
And Y is equal to -3.
-2,
Yeah.
0, 2. All right, so I want you to test them out for me. So let's test these two values. Um, x is 1, y is -2. So y should be equal to 2x minus 4. So test that out for me.
So we plug in -2 where we see Y. So
Mm-hmm.
-2 equals 2 times 1 minus 4.
Mm-hmm.
No, -2 is equal to 2 minus 4.
And 2 minus 4 is,
-2.
okay, so that checks out. All right, so let's try the quadratic. Y equals x squared plus 3x minus 6. All right, so test out that one for me.
So Y is equal to 6. That means,
No, we're still testing out these two
oh,
on the, so y is
Y is
negative
equal
2.
to -2
Mm-hmm.
and X is equal to -2.
1.
Oh, 1 squared
1 squared plus,
plus 3 times 1 minus 6.
all right, so let's see if we get -2 for that. So 1 squared is,
1,
and 3 times 1.
3,
All right, so 1 plus 3
4
minus 6.
minus 6 is -2.
All right, so these two solutions check out. Let's see if the x is -2 and y is -6. So again, y is equal to 2x minus 4. So plug in the values for me.
So Y is equal to -6. -6 is equal to 2 times -2.
Mm-hmm. All right.
Well, -6 is equal to 4 minus 4.
Um, 2 times -2.
Oh, I think it's supposed to be negative. Oh, I think it's supposed to be 1. And it's around x value.
X is -2. Oh, this should be 8.
Oh,
This should be a 8, -8. This one here. All right, so let's fix that. Um, so that should be a -8. All right. So we should have -8 here. All right. So 2 times -2 is -4 minus 4. All right. So the linear checks out. So let's try the quadratic. Y equals x squared plus 3x minus 6. So plug in the values for me now.
well, y is equal to -2 squared plus,
So where y is, we're going to put
oh,
-8.
-8 is equal to -2 squared plus 3 times
So
-2
we'll bracket the
minus 6.
-2 before we square it, plus 3 times -2 minus 6. All right, so what's -2 squared?
4,
And 3 times -2?
-6.
All right, so 4, 4 minus 6
-2,
minus 6.
-8.
Why do I
That's
have
supposed to
negative?
be 8.
Right. So this one checks out as well, right? So
Yes, miss.
look at those guys, and let me know if you have any questions before I go on to Imani. Look at them. Tell me if you have any questions.
No, miss.
All right. So I'm also talking to those in the chat. Those in the chat. Let me go and check if anybody has any questions or comments. All right. It seemed like so far so good. I don't see any questions. So that means it is Imani's turn. Imani's turn. All right, madam. Okay, so let's see now. So the next set of graphs we have y equals x squared minus 6 and y equals x. All right, madam, your turn.
Okay, miss. So the common points are 3 to 3.
So what is 3? X
Miss
is
X is 3
3.
and Y is also 3.
So when x is 3, y is also 3.
And for the second point, when X is -2, Y is also -2.
All right, and so right here is with intersection. So when x is -2, y is also -2. So the linear is a very special line, y equals x. So that means whatever y is, x is. This special line here. So once it intersects this line, we know we're going to have the same value for y as x. This is the line y equals x. So check for me, Imani.
Okay,
So
miss.
y equals
X
x.
is x squared minus 6.
Wait, check this one first.
Okay, miss. So y equals x, so y is 3 and x is also 3.
All right, so that checks out.
And
And
the second
then
one,
y equals 2x. Sorry, y equals x squared minus 6.
so 3 equals 3 squared minus 6. And 3 squared is 9. So 3 equals 9 minus 6. And 9 minus 6 equals 3. So 3 equals 3.
Okay, so that one checks out. So let's go over here now to this solution. Y equals x.
Okay, miss. So y is negative 2 and x is negative 2. So negative 2 equals negative 2.
Okay, so that one checks out. Y equals x squared minus 6.
So for the next equation now, negative 2 equals negative 2 squared minus 6. And mm, negative t squared is 4, since negative times negative is positive, and that's 4 minus 6. And negative 2 equals 4 minus 6, and 4 minus 6 is negative 2. So that also
All
checks.
right, so that checks out, right?
Yes, yes.
So just we're going to do another batch. Each person will get another batch, and then we wrap it up, right? So
Yes.
just to remind you guys, what we're saying is to find the solution of simultaneous equations where one is a linear function and one is a quadratic function. If we're doing it the graphical method, remember we could also just do this algebraic method, right? By substitution or factorizing or something like that. We could do that the algebra way. This is our graph class, so we're focusing on solving simultaneous equation using the graphical method. And how we do that is to plot both of the functions on the same coordinate plane, on the same graph paper, or the Cartesian plane, just different names, different terms for the same thing. So we plot our linear function, we know that's going to give us a straight line. We plot our quadratic function, we know that's going to give us a parabola or part of a parabola, a curve. If the coefficient of the x squared term is positive, the parabola is going to turn it's going to be oriented the way you see it there in the graph. Some persons refer to it as a smile. If it is a negative coefficient for the x squared term, it would be the opposite way, looking more like a frown or part thereof, depending on what the domain is. But the idea is we find the points of intersection. There are usually 2 points of intersection. Sorry, wrong slide. All right, so usually, we have our quadratic function intersecting. So let's say that's our plane, and this is our parabola. Usually it will come in and intersect the parabola. The line will intersect it at two distinct places, and we can take our x reading and our y reading for both of them. It could happen where the line comes in at a tangent and just barely grazes the parabola, at which point we would say we have one solution, or more accurately, two solutions that are identical, right? That is if it comes in. the line can come in and not touch the parabola. It could happen like that. Not usually, or at least not usually at this level. So you're either going to find one of these two, this one more frequently, where we have two distinct sets of solutions. So that's what we're doing. We're plotting the quadratic, we're plotting the linear, and we're seeing the points of intersection. We're taking our X and Y readings for both points of intersection, and we're also substituting each pair into both equations just to see if they check out. So that's what we're doing. So each of my scholars now will get another pair of equations to read. So who did we start with again? Was it John?
John, miss.
All right, so y is equal to x squared minus 6x plus 3. So that's our quadratic. And the linear y is equal to negative 2x plus 3. So that's our linear. Okay. So this is our linear and quadratic. All right, John, tell me the solutions and let's check them if they're accurate.
Okay, miss. Miss X is 0.
X is 0. Which one of the sets?
Miss, the first one, miss, where?
This one?
Yes, miss.
All right, so right at the solution here, X is at the origin, so X is 0 and Y is what?
Miss, Y is 3.
So Y is equal to 3. And for this solution here,
Miss, I can't really see, miss, but it's, miss, it's
you
going,
can't see it? Hold on. Hold on, let me move it up. Can you see it now?
yes, miss. So, miss, it'd be X is negative 5.
You sure?
Yes, miss.
Up to the x-axis. Up to the
Oh, yes,
x-axis.
miss, that's for, it's
So
X
X.
equals 4.
And by the way, guys, your graph would not look like this. You would take your ruler and you would draw your straight line. Okay. And for the Y now,
Miss, that's negative 5.
is John laughing at my dotted line?
No, miss, I'm not laughing at that.
Oh, okay. All right. So plug them in now and check. So the linear is Y equals 2x plus 3. So check it out. Plug in these two
Okay.
values.
Miss,
X is
Y,
0.
Miss Y is going to be 3. So 3 is equal to 2 times 4 plus 3.
No, X is 0.
Oh, yeah, oh, miss, I was looking at the wrong one. X is 0. Plus, so Miss X, no, Miss Y is 3. Miss Y is 3.
What's 2 times 0?
Miss, that's 0.
So we
Oh,
see that 3 is equal to 3, right?
it's,
So that one checks out. How about x squared minus 6x plus 4? Y is equal to. So
okay.
plug those in now.
Miss Y is the negative 5.
These two we're still doing, John.
Oh, yes.
We're
Okay,
still checking these.
Miss Y is 3.
So 3 is equal to
So 0, Miss 0 squared
0 squared
minus 6 times 0. plus 3. Yes, miss, that's obviously 3. 3 y is equal to 3.
So 3 is equal to 3. All right, check the other pair for me where x is 4, y is negative 5. So for the linear, y is equal to 2x plus 3.
Okay, miss y would be negative 5 equal to 2 times 4 plus 3.
Mhm.
Okay, so miss 5 minus 5 is equal to 8 plus 3.
Something not right here. X is 4, 2x plus 3. This don't add up, does it?
No, miss that would be 11.
Yeah, so what's wrong here?
Um,
X is 4, y is negative 5,
hmm.
2x plus 3, x squared minus 6. Oh, it's negative 2. It's a negative 2.
Oh,
Okay, so negative 5.
it's equal to negative 5.
All right, so that checks out. Let's do the quadratic. So y is equal to x
X squared
squared.
minus 6x plus 3.
All right, so plug those in. So
Okay.
y is what?
Miss minus 5 is negative 5 is equal to 4 squared minus 6 times 4 plus 3. Okay, Miss brackets first. Alright, Miss minus 5 is equal to 16 minus 24 plus 3.
All right, so what's 16 minus 24?
Miss 16 minus 24. Miss that would give us 8.
Negative 8.
Yes, Miss negative 8 plus 3 also negative 5. So negative 5 is equal to negative 5.
Okay, so this one checks out. All right, so Asar's turn.
Yes, Miss.
All right, Asar. Okay, Asar, so your equation is y equals x squared minus 5x minus 2 and y is equal to negative x plus 3. Can you see the solutions?
Yes, miss.
All right, so tell me what the solutions are.
The first solution is negative 1, x negative 1, y 4.
All right, so from here, straight down, dotted line, x is negative 1, and straight across, y equals 4. And this solution here,
Is that 5?
right, so straight up from the intersection, x equals 5.
And y is equal to -2.
And straight across to the y-axis, y equals -2. All right, so check out the pair of solutions for me. So the equation is y equals -x plus 3. Use this solution first.
So y is equal to -2 and x is equal to 5.
So -2 is equal to
Negative
5,
5, -5
-5
plus 3.
plus 3.
No, -2 is equal to -2.
Okay. And the quadratic, y is equal to x squared minus 5x minus 2.
So -2 is equal to 5 squared
-5 squared. Oh,
positive,
5.
but it's
Positive 5, yeah, squared minus
minus 5
5
times 5
times 5
minus 2.
minus 2. So -2 is equal to
25 minus 25 minus 2.
okay, so -2 equals, so these cancel out. So we're left with -2. All right, check these solutions. Y is 4, x is -1. So y equals -x plus 3.
Um, y is equal to 4. So 4 is equal to -x times -1 plus 3. So 4 is equal to 1 plus 3. And 1 plus 3 is equal to 4.
Okay, so 4 is equal to 4. And the quadratic y is equal to x squared minus 5x minus 2. Okay, so y is what?
Y is oh,
It's 2.
4.
So 4 equals,
4 is equal to -1 squared minus 5 times -1 minus 2.
all right, so -1 squared is what?
1,
-5 times -1.
5. But it should be +1.
Yeah, it's a positive one.
No, it's 1 -1 squared times 5.
Yeah, -1 squared is a positive one.
But over that side. Oh,
Where?
okay, I get it. So
Okay, so
1
1.
plus 5 minus 2 and 4 is equal to 4.
Okay, so that checks out, right?
Yes, miss.
All right, so far so good. So we have one left for Madame. And I'm not seeing any questions tonight. I'm not seeing any questions. So I'm assuming that everybody understands what's happening. Everybody, if you're watching over the video and something occurs to you and you say, oh, but I forget what Miss said about that, or now that I'm looking at it again, I don't understand how they got that. Feel free to post in the comments, post your question or anything you want to double check, post your comment or your question. And I'll certainly come back and respond. All right, so we have one question to go for Madam. All right, so I always like to shift over my coordinate plane to the middle there. And all right, Imani, so your question is, all right, so y is equal to x squared minus 3x minus 2. That's the quadratic, and the linear is y is equal to 2x minus 8. Let me shift it up like that. What did I do? Okay, so let me zoom it in for you a little bit. Can you see the solution, Imani?
No, miss, the profiles are blocking the solution.
How
Well,
about
yes,
that?
I can see it now. I can
Can
see
you
it.
see it now?
Yes,
All
miss.
right. Okay. So tell me the solution.
Okay, miss. So the first solution, when x is 3, y is negative 2.
All right. So this intersection goes straight up to x equals 3 and straight across to
Negative
y
2.
equals negative 2. Mhm.
And when the other solution is when x is 2, y is negative 4.
So straight up to where x is 2. So x equals 2 and straight across to y equals
4.
negative. All right, so let's check. Um, so y is equal to 2x minus 8.
Yes, ma'am.
All right, so we said what? What?
Um,
Use this one first. So
negative
y
2
is
equals,
negative 2. So negative 2
equals
equals
2 times
2
3
times 3.
minus 8.
Mhm.
And negative 2 equals 6 minus 8. And 6 minus 8 is negative 2. So negative 2 equals negative 2.
Okay. And
Um,
for the quadratic, y is equal to,
means for the quadratic, y is equal to x squared minus 3x minus 2.
all right, so we said y was what? Negative 2
Yes, ma'am.
and
Equals
x was
3
3.
squared minus 3 times 3 minus 2.
Mhm. And 3
Okay,
squared
miss.
is
3 squared is 9 minus 3 times 3, which is 6. Minus,
9.
oh, sorry, 3 times 3, which is 9, sorry.
Mhm.
Minus 2. And 2 equals 9 minus 9, which is 0. And 0 minus 2 is negative 2.
All right, so let's plug them now into where x is 2, y is negative 4. So rewriting the linear, y equals 2x minus 8. So y is negative 4, x is 3, right?
Mm.
This is the one where x is 3.
X is 2, miss.
X is, oh, x is 2. Okay. Right, x is 2. All right, so we would have a negative 4 is equal to 2 times 2.
Yes, minus 8. And
Mm-hmm.
negative 4 equal 2 times 2 is 4 minus 8.
Mm-hmm.
And 4 minus 8 is negative 4. So negative 4 equals negative 4.
Okay. And for the quadratic, y equals x squared minus 2x minus 2. So y is negative 4, x is 2.
2 miss. 2 squared minus 3 times 2 minus 2.
Mm-hmm.
So negative 4.
2 squared is what?
2 squared is 4, miss. Minus 3 times 2, which is minus 6 minus 3.
2. So negative 4. 4 minus 6 is negative 2. And negative 2 minus 2.
Negative 2 minus 2 is negative 4.
All right, so we have negative 4 is equal to negative 4. All right, so that part of the, I'm going to shift that part of the screen for those who are unable to see it. Um, all right, so that, can you see it now?
Yes, miss.
Still can't see it? Right, so those are the solutions. So what we have done to when we are substituting back into the equations, we're just checking our answers. You don't necessarily have to do this, except for your own satisfaction. You don't necessarily have to present this as part of your answer. This is just this part of it, the substitution part, is just to satisfy our souls that our solutions are correct. So if you are asked to solve quadratic equations, solve simultaneous equations, one linear, one quadratic, using the graphical method, what we did using the graph, just this part of it, just this part of it, where you find the intersection, you use your ruler to draw a straight line. It's not going to look like my sloppy thing right here. You'd use your ruler, straight line up to the x-axis, take your x reading, straight line across to the y-axis, take your y reading for this solution. For the other one, straight up to the x, take your reading, straight across to the y, take your reading. That is the solution. And you would write them as, you'd write it here beside the axes, what the solutions are. And you can also write it in coordinate form. So you'd put in your brackets. So when x, so for this one, when x is 3, y is negative 2. So we'd have 3, negative 2. That's one pair of solutions. And the other pair would be when x is 2, y is negative 4. So 2 on the x, negative 4 on the y. So you could write your solutions like this, as well as x equals 3. So when x is 3, y is -2. When x is 2, y is -4. And that's your answer. This part of it you can do on rough work just to check to satisfy yourself. Or if you have time, you can head up something like check, just to check and do your check. And if you want, you can submit that, right? So that's how we solve simultaneous equations, the graphical method, when one function is a quadratic and the other is a linear. And if you want to see how to solve two linears, just go back, look up the video that we did last week, so the one before this, solving quadratic equations where two linear functions are present using the graphical method. And it's the same principle. It's just that this time you're just going to get one pair of solutions because the two lines are going to cross each other at just one point of intersection. And that's the wrap. Thank you again, my faithful scholars.
Welcome, Miss.
I appreciate your participation, and I'll see you tomorrow when we do algebra.
Bye, Miss.
Okay, bye Asar, bye John, bye Imran. Bye to all the scholars in the chat, even though you were not posting your answers, but I'm using that as a good sign to indicate that you're understanding everything that we did tonight. If not, please watch the video again and this time post your answers and comments. I'm going to play for you again our schedule of live classes so you will always be on top of things and you will know when to tune in so you don't miss a thing. Hello CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.